Today we are going to have a brief introduction of touch panel technology. Normally, there are a lot of touch panel technology available in the market, but what what we are going to focus will be the technology, what we can offer by our company, by our display. That is a resistive touch panel and a capacitive touch panel. So this is our company's milestone. So recently we invest a lot in the capacitive touch panel, and we forecast that in the middle of the year we are going to produce, the capacity will be 1 million pieces per month for 10.1 inches. If the size is smaller, so we can produce even more. So normally, touch panel we can offer can divide it into two categories. One is resistive touch panel and capacitive touch panel. A resistive touch panel can also classified into digital touch panels. That means there is a fixed touch area, like a thermostat application. That is another is an analog touch panel. That means that you can touch anywhere. It is the same for a capacitive touch panel. It can be a digital capacitive touch panel. That means only fixed area that can be touched, and also a projective capacitive touch panel. That is very similar to the iPhone technology. First, we will introduce the resistive touch panel. The resistive touch panel, we can produce 4 wires. That is the most simple and most cost-effective resistive touch panel. And actually, it's very simple. You can see the structure of resistive touch panel is a glass with ITO. I believe everyone know what is ITO. It is indium tin oxide. That's only a commercially available transparent conductive material in the market. Okay, and so there is some spacer between to keep the gap between the glass and the top film, and this is a top film with also with ITO. When use a pen or stylus or finger to touch that, so the upper ITO and the bottom ITO contact together to make it the short or conduct. So in that case, we can see that we if we use resistive touch panel to locate the for example, it is a top ITO, so that is this touch point to the edge there is resistance, and also the top to the right hand side there is another resistance. It's the same thing for the bottom one, and so to the top there is a resistance and to the bottom resistance. So in that case, just like a coordinator, so the resistive touch panel controller can locate this touch point. So then we'll know, where is the touch point. So it's very simple. And for capacitive touch panel, for us, we only produce projective touch panel. So you can see that for capacitive touch panel, so if it is no touch, that's fine. And then when it is a touch, so you will see, if it is a too conductive electrode getting very close. So then, in between, there is projective capacitor, projective capacitance, and so it is a sensor. Okay, and when the finger very close to the sensor, then the finger itself will produce the finger capacitance between the two electrode. So actually, this is around. This should be CF, not CP. This is a CP. That is a projective capacitance, and these two is finger capacitance between the two electrodes. So in that case, with capacitive touch panel controller can sense the capacitance change. You can see. Then we can locate the, the the position of the touch. So you can see actually this is a surface capacitive touch panel. Okay, so there is some electric field. So it is a pattern like this way. Okay, so actually for capacitive touch panel, so you can see there are two layers, with a diamond shape, and one is yellow and one is blue. So in that case, when it touch, so it will have a capacitance sensed in all these patterns. Okay, I will explain more for that. And you can see that when the finger, touch this area, so actually the controller can sense the capacitance change between this electrode, Actually, this electrode should be very close. And in order to make it, you can see, at the bottom there is one layer of electrode, and there is a bridge there. And in another layer, so we need to make a bridge. So in that case, to make this into another layer. So otherwise, it will separate and not conducting. So normally, as a bridge, we use very conductive aluminum area to aluminum material to conducting the two electrode. Okay, and of course that need to be separate layers, otherwise it will get short. So you can see if from the side look, we can see that this is the X direction sensor, and so there is an isolation area, and this is a Y sensor, and there should have a bridge, between that. It is really like a bridge, okay, but the bridge can also at the bottom, okay. So in that case, you can see X, that is connecting with a bridge at the bottom, and then there is an isolation layer, then the Y direction sensor that is on the top to make it separate. So when the finger get very close to this electrode or sensor, so the capacitance will change, between the X and the Y electrode. And this is a process, capacitive touch panel production process. And first, we have a glass, of course. It's a sensor glass. Then we use ITO to sputter it onto the glass. Then we use a mask to etch that. So in that case, we get the first layer This is a bridge. We get a first layer of the sensor, okay, of the electrode. Then we have uh, another layer. This is made it into the bridge. Okay, made it into the bridge. Then to have another process to produce uh, another layer of electrode. That is, for example, this is a X uh, electrode. Another process will be Y electrode. So it's the same thing. Why it is called the moly uh, etching? That is because there is a metal that is a moly that is used for insulation protection for the aluminum material. Otherwise, aluminum will be easily to be oxidized. So in that case, you can find the structure of or touch panel sensor process. Okay, you can see this is a one glass solution that is a cover lens and the touch panel solution. You can see um, this is a sensor. This is a sensor, and then this is a cover glass. Okay, there's a cover glass because the sensor is a very fragile and easily to break. So we need to have tempered glass in front. We call it cover lens to protect the sensor, and use OCA glue. That is optical adhesive to glue the cover lens and the sensor. So in that case, we can get a module, touch panel module. So recently, the one glass solution is very hot, and actually uh, that can waive this sensor glass. So actually, all the process will be produced on the tempered glass, actually the cover glass. So in that case, we can waive using this piece of glass for sensor. So in that case, we just have one glass solution. It's a thinner and but not necessarily low cost right now. From the front view, we will see that this is front of the cell phone capacitive touch panel. You can see there is a PC here. So what we can see is cover lens. Actually, the black uh, ink that is printed there to print the logo, print the and also we can cut the hole here to make a switch here. So and also cut the window. Normally we use a CNC machine to cut it. If we look at the back side, we will see that of course this is a touch window, and also there is some XY layout here, all connecting to the PC. And normally there is a touch panel controller on FPC, but this drawing doesn't show. And also there is some icons, some logos, and also in order to protect and to have the consumer not to see the layout, normally we print a black ink in front, or white ink in front of the cover lens. So in that case, to protect and to make this more beautiful looking. And this is a OGS. OGS means one glass solution. We mentioned that we don't need to have the glass for the sensor. Actually the sensor will directly use for produce on a cover glass, a cover lens. So first we have a normal glass, and then we will temper it. Normally we use a chemical temper it to make it very strong, and to make it more than 3H hardness. For a cutting glass, normally it was 7H. Okay, and then we will um, make a sensor on the cover glass, and then we will cover it, and then we will drill the holes and bevel the edges to make it smooth, and then we get an individual uh, sensor. That is a one glass solution. Okay. So actually, there are a lot of technology for capacitive touch panel, and sometimes it can be very confusing and very cautious for the production uh, equipment investment. Actually, because most of the market for capacitive touch are, for cell phones and for iPad, some kind of application. So in that case, it is a very cost effective, and whoever can develop very reliable and cost effective solution, then the manufacturer can win. So we are very cautious about the equipment investment, and very get a lot of investment into the research and development to see what the future technology will be, mostly cost effective and reliable. And for a capacitive touch panel, there were a lot of types, and various kinds of capacitive touch panel. There is GG2, that always have a cover lens. Okay, always cover lens, even the one glass solution. So we can see that there is a cover lens. Okay, there, and so for GG2, we can see that inside there is a glass. Then we produce X channel and Y channel electrode on it, on the glass. Then this is a sensor. Then we use adhesive to glue between the TFT LCD and as well as cover lens. Okay, this is a very traditional one. This process is patent by Apple, so we cannot use this technology to produce touch panel. And this is also called DITO, the DITO, DITO. So we can see there is DITO. Okay, and in our manufacturer, mostly we use GG. Okay, G plus G. So it is another idea is just to use one glass is the same, but instead of the X channel, Y channel in the two sides, both sides of the glass, it is on the one side. Okay, in order to avoid the patent by Apple, so we have to use a different way to produce the touch panel, and then the process can be a little bit complicated because X, Y need to have an insulation layer between it, and but actually the principle is the same. The one glass solution, and this is glass type, and this is a film type. Actually, instead of using glass, so we can use a film. Okay, we can use we can have a cover lens, produced with X channel, and a glass film produced with a Y channel, and then use a glue to glue together. Okay, this is a G1 film. It is also very promising technology, and a lot of companies, including our company, also investigating this technology. And this is a GFF, we can say that we can see the film with with a X, we produce X channel in one film and a Y channel in another film, then glued it together. So in that case, uh, that can produce a pretty high yield, but the problem, is a lot of layer between that. So actually, the reliability is not as good as glass plus glass. Okay, and also GF2. GF2 means that it's a little bit similar to the technology patented by Apple. So the film, uh, there is a film here, and then we have two layers. X on the top and Y at the bottom, and then um, we glued with a cover lens and the TFT LCD. So it is an idea for that. And GF, it is the same thing like the production we are having now, GG. So we have a film that is produced with X and a channel and a Y channel in one side, and then we glue together. So um, normally glass process is pretty stable. The film process a little bit more difficult. So yield is pretty low right now. But a lot of people think that because the film can produce roll in roll, and it can provide support promising cost-effective solution for the touch panel. Okay, so for the cover glass material, normally we have glass lens. Okay, and normally it's a chemical tempered, just in case it will get a broken. Okay, so the most famous one is a Corning Gorilla glass and also Asahi Dragon Tail glass. So this were the two toppest quality glass for lens. Okay, we can also use a PMMA lens and a PC lens, or PC plus PMMA lens. So this plastic, but the good thing it is cannot broken, but the downside will be it will be flexible and not reliable and easy to get brittle, especially in the harsh environment, not as stable as a glass lens. Okay, and also the touch for the glass lens, it is because it is very hard, it's very smooth, so the feeling is very good. And the assembly of touch panel and the lens. So in that case, we know that the most popular one is G plus G, that is a glass sensor plus glass lens. So we have ditto and ceto. Okay, so ditto means that the ITO on the both side of the glass. Okay, so ceto, that means the ITO both XY ITO, that is on the single side of the glass. So we have glass sensor plus PT lens. Okay, that is a soft to hard. This is a hard to hard. Okay, and also have G plus F is a PT sensor with a glass lens. It's a soft to hard, and of course, it's the most famous. It's a one glass solution. And recently, iPhone use in-cell touch panel. Okay, can be stressful, and because if actually there is no touch panel uh, on the TFT, on the LCD. Actually, all the uh, touch panel that is embedded inside the LCD process. Right now, only Sharp, LG, and Samsung can produce that. The good news that we heard that it is still a long way to go, and it is a it's a it is pretty expensive process, and we will think that in the future, one glass solution might be the best one. Okay. and uh, we can compare with a different technology of touch panel. So now we will not just we will not compare as another three, and it is used for other application, and our company will not offer. And for we just compare resistive and capacitive touch panel. So light transmission, uh, resistive touch panel is not so good. So sometimes in order to avoid Newton ring, so we have to use anti-glare film. So that make the transmission even worse. So, but the capacitance touch panel, CTP is very good. Okay, so the touch, a finger touch, so it is excellent. Both excellent. Use a finger touch. For the glove touch, so resist touch, so it is good. But the capacitive no, because you cannot generate capacitance between the electrode and the finger. And stylus touch, so excellent, is not so good because the same thing. There is no capacitance there. So, but we have to use a special purpose stylus to transfer the human body capacitance to the stylus. Okay, and durability is not so good because we have to press it down and make the ITO contact. The ITO, if you touch it, million times, it can get cracked, or the plastic can be get scratched. And but a capacitive touch, actually, you don't need to, touch very hard. It just gently touch that, so you will be good. And resistive to the water drops, so both are pretty good. And the cost, so resistive touch panel, especially for 4-wire resistive touch panel, that's a pretty low cost. But capacitive touch panel, in this table, say it is not so reasonable. So that is back to several years ago. Right now, the CTP price is drop sharply, and we will see that in the next 1 or 2 years. So these two technologies can be, maybe the same price. That is a very good, very good, news for the consumer. Now I'm introducing about the OCA and air bonding. Actually, how we can use bonding process, between the LCD and the touch panel. So actually, there are two ways. One is optical clear adhesive bonding, is we call it OCA, and another is air bonding. That is some people also say it is a pyramid cell or double-side tape cell. Okay, it is a low cost, is a very high cost. So there is some explanation here. So it is not a reworkable, it's a reworkable. But OCA look beautiful, much more beautiful than air bonding. And why? So that's because, for example, it is ambient light, and if it is air bonding, so there is several layer of reflection, and any the light, if it's transmitted to any substances, actually, different substances, so that will have the reflection. Okay, reflection. And if the air bonding, when the light, from the air to the glass, there is a reflection. From glass to air, a reflection. From air to uh, the TFT module, there is another reflection. But for the optical bonding, so we can produce OCA. It is a reflection index. It is almost the same as glass. So when it is getting through only the surface reflection, so we can save around 8% of a reflection. One the reflection will be around 4%. If it's use a backlight, is the same thing. We can see that there's a 3-layer reflection, but for the optical bonding, so OCI bonding, so it is just one reflection. We can, compare with these two, so we can see the brightness can be increased 8%. You can see the difference. You can easily see the difference. What is OCI bonding and air bonding. Okay, that's all for today.